In this video, we want to learn how to differentiate inverse trigonometric functions. Okay, so here's a table for you that shows the 6 inverse trigonometric functions and their corresponding derivatives. So we have the first ones to be sine inverse of x. Okay, sine inverse, they're just the inverse of sine. Okay, so let me show you something. If we have sine something, let's say sine x, all right, is equal to y, all right? Good. Okay, so this is sine of an angle. So here x is considered to be an angle, will give us a result, okay, a value as an answer. And then sine inverse is just the inverse of sine, okay, that will, now if sine takes something in the domain, okay, and put it here in the codomain, that is, sine is a function that takes every thing it has, okay, to the range set. We may need another function that will reverse the action, okay, and that function is called the sine inverse, okay, good. Or maybe you can also denote it as arcsinx, right? You can also call it arc, just then you put down the sign of something, let's say in this case is x. So we can call it sine inverse of x, or it can also be denoted as arcsinx of x. Good, okay. So, but just for brevity, make use of sine inverse, and okay, then arcsinx is just the same convention. All right, so let's figure out how to differentiate this kind of function, right? So if you are given sine inverse of x, first of all put down sine inverse of x. You want to find the derivative of this, okay? Maybe I can call this y. I can say let y be sine inverse of x, okay? So our aim is to find what the derivative of y is with respect to x. So let me put this down as our goal, okay, is to find the y, the x. That's the derivative of this function with respect to x. Okay, so what I will be starting off with is from the definition of sine inverse, that if y is the sine inverse of x, okay, that means we can take the sine of both sides from this equation. That would mean that sine y is equal to x. If you take the sine of y, it is sine y, and then if you take the sine of sine inverse of y, it's going to be just, if you take the sine of sine inverse of x, it is just going to be x. Okay, just from the definition of composition of inverses. All right, good. And now, this is only possible when this y here is a number that is, okay, any real number, and then x is going to be just between -1 and 1. Well, that's just by the way. Okay. And now, we've got this, all right? Good. Okay, so we have that sine y is equal to x. Anyway, we can differentiate this implicitly, okay, with respect to x, given that y here is a function of x. So we are going to differentiate this with respect to x. So I'm going to put this down as a derivative with respect to x of the left-hand side, which is sine y, all right? And then also do the same thing to the right-hand side. I put down the derivative with respect to x of x. So when we differentiate sine y with respect to x, notice that this y here is a function of x, so you're going to be using the chain rule, just as we differentiate an implicit function. So the derivative of sine of something will be cosine of that thing, which is y, right? And then we multiply it with the unknown function here, y, which is dy dx. So I'm going to multiply it with dy dx, okay? Good. So you multiply with dy dx, and then you differentiate sine of y. Good. Okay, so we have here that derivative of x with respect to x is just going to give us 1. Good. Okay, so from here we can put it down that dy dx is 1 over cosine of y. Well, this would have been a nice place to stop, but notice, since we are looking at dy dx, okay, it is a y written in terms of x, the derivative should also be a function of x. So we will look for a way in which we can eliminate this cosine y and put in something in terms of x. Good. Okay, so we are going to use a very well-known trigonometric identity that tells us that cosine of y is a positive square root of 1 minus sine squared of y. That is from the fact that cosine squared something of an angle is the same thing as 1 minus sine squared. So to get rid of the square for the cosine, we take the square root of both sides. And And then that gives us that cosine y is the square root of 1 minus sine y. So in place of cosine y here, I can just replace it with the square root of, so I put it down as 1 over the square root of 1 minus sine squared y. Good. We are not done yet because what we have here is still a function of y. So what I'll be doing one more time is this. Notice that from this equation here, okay, we have it that sine y is equal to x. So in place of sine y, I'm just going to be putting x. Okay, so when we do that, we're going to have that dy dx, that the derivative of that function is now going to be 1 divided by the square root of sine y is x. So if you square that, we square the x. Good. And this right here is a function in terms of x, which satisfies the first function that we have right there. Okay.